to do number 2 first, if I can find my pen, because I want to make sure you understand that this concept, can be asked a different way. So right now it says, what's the limit as x approaches infinity of that? Remember, when x is approaching infinity, our limits are always about who has more power. Think of like infinite power. On the bottom, x squared is controlling the end game. It's the most powerful. On the top, what's the most powerful? 3x squared. Yes. And the plus 1 isn't doing anything. And when we have tied powers, we steal the coefficients. That should have been easy, correct? But they could have phrased this another way without the use of a limit. So I want to make sure you understand, because sometimes they do. So if you got that one, you'd be, oh, that's easy. But sometimes they'll approach it with different words. As I go to infinity, if my limit is 3, what else could that have been phrased as? They put it in limit notation, so that's really nice. But they could have said, what is the horizontal asymptote? Yeah, so make sure you understand that those two things are synonymous. They mean exactly the same thing. This one you'd have been lucky. Oh, sorry, I stole it.
Later today,
No, it's for geometry. I should have returned them. The next one I want you to do is, look at this one, should be easy, the continuity and differentiability. Related rate, I just want to go through the process again, because we didn't have we had a full existence theorem day, we had a full rate in, rate out, delta day, but we haven't done a full related rate day. So we've got an ice sculpture in the form of a sphere, and it's melting, so it's getting smaller, but it's maintaining its spherical shape. The volume of the sphere is decreasing, so you're going to pick this apart as you read it, at a constant rate of 2 pi. So negative 2 pi would be right there. It's decreasing at a constant rate, and it's the volume. So they're giving you dt. At what rate in square meters per hour is the surface area decreasing? So I need ds dt, boom, when the radius is equal to 5. So I just want to repeat our related rate process. We pick it apart, and then we need a formula for what we're trying to find. They gave it to me. Okay? So you would write S equals 4 pi r squared. That's the surface area of the sphere. Then it starts to melt, and that means the sphere surface area starts to change. So we need to take the derivative. You bring the 2 out front, and you're going to get 8 pi, because that's just a constant, r times what? dr dt. Okay, if that's a t squared, yeah, it'd just be 2. But so 2r times dr dt. Once you're done, you plug in what you know, and I know that we were stopping this when the radius was 5, correct? So my ds dt will equal 40 pi times dr dt, which they never told me, which means somehow I can find it, and it's hidden, okay? So what have I not used yet? The volume. Exactly, you guys. So, and they gave me the formula for it. So they're basically telling me in the stem of the problem, you've got 2 things going on here, and you need to use them both. I started with the S because that's what I'm trying to find. So let's go write our volume formula down. 4/3 pi r cubed, correct? Let's go take our dB dt because the volume is shrinking as the surface area is shrinking, right? I bring the 3 out front, it's going to cancel. I get 4 pi r squared dr dt, correct? And I know everything in this one because they told me it was shrinking at a rate of 2 pi, and they told me that r is 5. And I'm going to quit with that one because you'll just solve for solve for dr dt and then shove it in the other one. I just wanted to go through the related rate process again, okay? If you don't know if you'd be comfortable doing that, the answers are on the back. You can finish it up later. I'm just throwing some stuff at you that maybe we haven't talked about for a while. Slope fields we talked about recently. This we talked about yesterday. So I want to go to number 7. Okay? Number 7 hasn't been talked about for a while. It's really easy to, it falls in that easy to do, but hard to remember category because it's a very small thing that we did. So I am given f as an integral, and they're telling me to find the derivative. So they're telling me I need to do the derivative of f. F is an integral. Let's see if anyone remembers what you do in this case. I am to find the derivative of f, and f was an integral. What happens in this case when you have a derivative of an integral? This is dump and derive. Dump the top, and think of all those, the derivative of the integral, dump and derive. Think of a triple D, right? So what we do is we dump this in for the variable. It doesn't matter what's constants on the bottom because when you do derivatives of constants, it wipes it out, correct? When we do the derivative, we get, the dump, we get 1 plus ln, right, x squared. If that's what you did, you would get x cubed, x cubed. And then we need to multiply it by what? By what? The derivative, 3x cubed. If there's just an x on the top, you dump it and do the derivative of the derivatives 1. And then we would plug a 2 in and simplify it. So I am not going to do that. All right, I'm not going to do any simplifying today. This was an ELK time. Who in here was in that ELK time that's on the back board? You 3 or 4 should try that, but we're not going to do it. We also are good at averaging, I hope. Average value, what's the first thing you write down? An average is a total divided by something, right? And I'd be dividing by 4 minus negative 4, 8. So make sure you put a 1/8 in front of it before you start accumulating area. But that one's not a big issue. Last one we'll do together is number 10 here. Because we didn't spend a whole day on exponential growth. We had it in one problem earlier in the week. So they're telling me I've got a solution to this differential equation where the rate that something's changing over time is directly proportional to the amount present, and they're asking me to find y, or f of t. They're the same, correct? Which means you know you need to integrate. You can't integrate till you separate, which you could do, but it's a time waster, because I gave you a little mnemonic for this situation. What was it? Y equals what? C e to the kt. Yep. And c is the amount present at the start, which you're not used to being handed to on a table. But that's no problem. Y is equal to 4 e to the kt. That's what I know so far. Out, out, out. I'm done. Really. But I would challenge you to remember how you find the k. Do you guys remember how to find that k value? You plug the other point in. Yeah. So you'd say y was 12 equals 4 e to that, and that was 2 times later. And if you solve that for k and plug it in, you'll get that exact same one. All right? So those are my choices. If you want to do the other ones and see if you can get the answer in the back, do so later. Oh, I did want to do this one too. We were good at this when we did it, so we haven't reviewed it much, and it hasn't popped up as a most missed. But I still like to discuss it because this is a very common question. Being given a graph of f prime and being asked what the original must have been, or being given the original and asking which one's the derivative. So remember what the derivative tells you. This is y equals the slopes. They're negative here, correct? So what must my function be doing from 0 to 1 for sure? Decreasing. So let's go look if we can eliminate any of them. This one's out. And that's the only one. Okay, so let's move on to the next part. From here to here, what must y have been doing the whole time? Increasing. And you might say, but there's cusps right there, so it doesn't exist. The second derivative won't exist, correct? The derivative exists there. It's the same, so the slope is the same at 2 as it is at 4, and I'm increasing the entire way. And it has to be continuous, right? Because the derivative exists. So, well, this one's out because we're decreasing. This one's got problems. Because if f was discontinuous, I wouldn't have had a derivative existing there, correct? So we're at a. It increased the whole way, right? Good, we're done with that one. Next up, we're going to take a look at an FRQ. We might not go through all of it. This is calculator active. It should be easy. That's interpretation. Should be easy. This guy, let's try it. Let's see if we've got those existence theorems down. Because whenever it says guarantees a number C, it's an IBT, an MBT, or an EBT reference, or kind of all of them. So go ahead and read that. Maybe start a graph. At 2, you're up at 17. At 5, you're up at 17. And then it asks you about the derivative. And you should know for sure based on last week whether they're referencing IBT or MBT. Which one is it? MBT. For sure, right? They're not asking you whether f has to equal 5 at some place or something like that. They're talking about f prime being 0. I see the slope of the secant line being 0, correct? So the MBT guarantees that the tangent line has to have a slope as 0 as long as the function is continuous and what? There. Done. How are those? Because those were the trickiest ones of the 14. This is College Board's item sampler. Like, here's a sample of stuff you should know how to do. Now we're going to hop on and talk about number 15. It's calculator active, so we're not going to take our calculators out, but know how to use them. So a rain barrel's collecting water. Whenever I see this, I'm like, okay, rain barrel collecting water. I just go like that. And it's going up. So I go like that. I like pictures, especially when the stem of the problem is that long. All right? So it says the height of the water in the barrel is increasing at this rate in feet per hour. They're giving you the rate that the water's going up, correct? And then it says at time 1, the water's already at 0.75 feet. And it asked me the height of the water, it is at 2 hours. So an hour later. Well, for sure you're going to have the 0.75 in there, correct? For sure. Plus you're going to have how much accumulates from 1 hour to 2 hours, correct? But they didn't give me a model for feet of rain. They gave me feet per hour, right? My answer needs to be in feet. That should trigger. I need to integrate, correct? How much accumulated from 1 to 2? And you go R of t dt, and then maybe you would check your units. R of t is in feet per hour. Change in time is in hours. When I'm done, this will give me the hour change, correct? And then you just run it through your calculator. And I don't know, what button would you use on your calculator? Math 9 for any integral, and Math 8 for any derivative. If it's calculator active and you are integrating or differentiating, you should not be, right? You should be making your calculator do it. Now let's look at 2 FRQs. I don't need to do particle motion. We're good at it. I don't know that we'll do the whole thing, all right, but we'll do parts of it. So this would have been calculator active, it says, if you had this one. And we've got this water in a conical storage tank, and it's modeled by a differentiable function. I immediately go, oh, also continuous, in case they ask me any IBT, MBT stuff. So when I see that, I don't actually know what it's going to ask me, so I haven't looked at this. But there it is. It says, at time 0, the height is 25. So I'm going to go T0. The height is 25 meters. So this would be the height at that time. And then they give me this rate again. And it's an ugly rate, but I have my calculator. Okay, so remember, they are giving me H prime, not H. The rate that the height of water is changing. All right. So when I read letter A, and it says, when the height of the water in the tank is H meters, the volume is. At what rate? What is that question? It's a what? Related rate. Correct? We just did one, so I'm not going to do it. All right? Be careful if you have two variables of change when you take the derivative. Because what rule do you need on the function part? Product rule, unless one of them was a constant, right? And then you should put it in the beginning. So for a cone, radius is changing. For a cylinder, radius not changing, right? Two things flying away from each other, the distance between them changing. Ladder falling down the wall, not changing. All right? So we're going to go look at letter B, and I'm going to slow down. Okay? So letter B says, what is the minimum? So are you thinking relative or absolute? I'm thinking absolute. I'm thinking I'm going to need a candidate table to put all my possible candidates for the absolute minimum height of the water. Who goes on my candidate table? Yes, and this is about height of the water. So my table becomes T and the height of the water at that time. Unfortunately, they have not given me H of T, so I've got to figure this out. So who goes on my table, though, for sure? 0 and 24. At 0, it was handed to me. All right? It started at 25. Sometimes instead of, it might say there were 25 people in the movie theater before a fire started and they all started exiting at a rate up, right? You often are given a starting amount, and that's so you can kind of get moving from that amount. So if I wanted to know how much water there was at the end, I would include, so here's how I get my H of 24, correct? Are you good? I would say it's got to equal 25, the amount there, right? And then whatever was accumulated from, and they gave me H prime, so I've got to do the accumulation. That's it. Integrate my derivative to get to H. What would be the limits? 25 at the start, plus what accumulates from where to where? 0 to 24. Where would you get this? Off your calculator, right? Because it's calculator active. So you would not go try to integrate this nasty function, even if you could. You just go 25 plus math 9, blah, 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 enter that. And something will get spit out here. We're not going to spend, you should know how to do that, right? But there's other candidates, right? You can have a minimum at the beginning if things are always increasing, a minimum at the end if they're always decreasing. But where else can they occur? At the critical values, correct? So you're going to now have to figure out what the critical values are of H. Critical values occur when the derivative equals 0. And you have a calculator, right, Henry? So you would just graph H prime with T and see where it does what? Yes. And if there's two places, I would put them both on here. But since it said minimum, you're actually only looking at relative mins for absolute mins, but do you remember why I said just put them all on there? So you don't have to explain why you're not doing both. Okay, so that would be that one. But then there's a tangent line equation. There's always an equation of a tangent line. It says the line tangent to the graph of H at 16 is used to approximate. Well, I'm going to stop right now because what two things do we always need for a tangent line? What? Point 16 and H of 16. I'm going to have to find, right? You either find it from a function or a graph or a table, right? And I also need the slope there. Which one's easier to find, H of 16 or H prime of 16? The prime. I just plug 16 into my derivative function, correct? And what do I round it to? A minimum of 3 decimal places, not 3 minimum, right? So 22.439. I would say go to 4. It's a minimum of 3. All right? Anywho, how would I find h of 16? The same way I found h of 24 and h of whatever the critical values were. I'd go up here and say, well, it started at 25 meters, plus from 0 to 16. I'd go to my calculator and crank that puppy out. Keep in mind we have used this a lot. Do you want to type it every time? So what did I suggest to do when you have an icky function in a calculator active problem? Put it in Y1, right? If you're going to be using limits a lot, store them in A or B. If you're going to be using a function a lot, bars, Y bars is, so then you're not typing it in all the time. Okay, next one up. Always a graph analysis question, but what they ask and what they give you, you can never predict. Okay, so on this one, and this is the last one we're going to do, and then I'll send you off to something else, okay, on your own. So it says the graph of a differentiable function, I'm thinking, okay, it's also continuous in case I need my existence theorems, is shown above. It has horizontal tangents at -1, so you're 100% sure we turn here, and you're 1,000% sure you turn there, and at 1. That's what they're telling you you're for sure. Then it's giving you the region's area. They say this has an area of 5. This has an area of 4, but what number am I going to put in it? -4, perfect. This has an area of 5. This has an area of 3, so I'm picking it apart as I read it. This word right here, if you listened to what you were supposed to listen to yesterday, I talked about it. So I want to see if you can write me an expression for G, because you'll notice all of the questions are about G. G is the antiderivative of F. So I need to know what G is doing, because all the questions are about G, and I have the graph of F. Okay? That's the kicker to this. If you don't know what that means, you can't answer any of the questions. So that's why yesterday I focused on this word. We know what a derivative is, right? If G was the derivative of F, I'd write G equals F prime. But when G's the antiderivative, I write G of X equals what? What does it equal? The integral. Then you can go F of X dx. Sometimes they use a different variable just so you're not getting messed up. Okay? So it is the integral. Very good. They tell me that G of 3 is 7. So what they're telling me is that by the time I get to 3, I've accumulated 7. Good with that? So now let's go look at the questions. It says find all values of x such that G has a maximum. What does that mean? If a function has a maximum, relative maximum, its derivative, so I'm writing that down, right, must do what? Change from what? Positive to negative. So I'm going to write G prime change. I'm thinking it out so that my justification is actually going to be in front of my answer. I like to reverse those so that I think it out. So G prime change from positive, and I'm just going to use plus to minus. You would write it out. And then I'd ask myself, well, what is G prime? What is the derivative of the integral? It's f of x, correct? And my y values are f of x. So it's kind of nice. I'm just looking for where the y values change from positive to negative. What would be my answer? At -2. At x equals -2. And I don't need to justify it because I put my thought process in front of it. It got me going. So that's how I answered these graph analysis. When is G concave up? Well, I'm going to ask myself, what has to happen for G to be concave up? G double prime has to be what? Greater than 0. Well, I have to go back up here. And I have to say, well, what is G double prime of x then? F prime. Right? Well, if I need F prime, which is G double, to be greater than 0, if I'm looking at the graph of F, these kids struggle with these. You guys were good at them. It was kind of a strength of ours this year. I don't know why. But It was good, but I want to hit it because there's always one. It's not always the same information, though. Does that make sense? Or the same questions. So then it says, what do I need F to do? Increase. So I pick the increasing intervals up there. All right? Then it says find the value. The minute I see this limit sitting in the middle of a FRQ, what kind of, I haven't even looked at it yet. But what am I thinking? It's probably L'Hopital. There was a year it wasn't. So you do need to make sure that the top and the bottom are both going to what? 0 over 0 or infinity over infinity. You have to do that separately. You can't just write equals 0 over 0. They don't accept that. So you have to analyze the top of the function. The limit as x approaches 0 of g of x plus 1 equals. I'm thinking it's 0. If I don't know how to calculate it, I think I just put a 0 down. But let's go see. Somehow I'm supposed to know what g of 0 is. Correct? Let's go back up here and see if you guys can figure it out. How do you think I'd figure out how much snow there was here? It gave me an anchor. Correct? What was my anchor? G of 3 was 7. I'm going to go backwards. You're nodding, right, Luke? Because what am I going to do with that 7? Remove the what? 8 that accumulated to get there, right? So when you go backwards, I'd say, well, I must have increased 3, so I better decrease 3. I must have increased 5, so I would have been at -1, which does give me a 0, so that's kind of nice. So I'd write equals 0. The bottom, the limit as x approaches 0 of twice x is 0. So I've just shown that the top and the bottom are going to 0. So what can I now legally launch into? L'Hopital. So L'Hopital says the limit as x approaches 0 of the derivative of the top over the bottom. And where would I get g prime? G prime is f. F of 0 is 0. The answer is 0. Okay? How would that one have gone for you? Okay? Now let's see h. Oh boy, they give me another function. What the heck's going on? So I'm going to have to go put h in here, and somehow I must know how to integrate this, because this one's not calculator active. So I can't math 9 it. So I'm going to go from -2 to 1, and I've got 3f of 2x plus 1 plus 4 dx. So start me out. What's one thing I'll do, Alexa, with that big ugly mess? I'm going to pull the 3 out front, so that I'll be integrating f of 2x plus 1. What else did I suggest to do with these a couple days ago? What about that 4? Do it separate. All right. Which one do you, or should you, know easily? This monstrosity or this little fella? What's its area? What's the antiderivative of 4 from -2 to 1? It'd be 4x. Yep, you can go use the calculus. Let's go do it. It'd be 4x evaluated from -2 to 1. Correct? Which would be what? 4 minus -8. It's 12. What's another way you could have done it? Yeah, it's a height of 4 and a span of 3. So it's adding a 3 by 4 rectangle. So I'll definitely put a plus 12 on there, even if I don't know how to do the other side, because I'm sure there's a point for each piece. How do I integrate when I have a function inside of a function? You sub. Who said that? You sub. Who's you? Almost always. The what? Inside function. But now everything's got to go to you. So I'm going to do a limit change. Do you see how you know all of this? It's there. It's just a lot that you have to remember in AP Calc. So I'd be going from -3 when I put a -2 in up to 3. So now I have my new limits for u. So let's go write that down. I'd have 3 and I'd have -3 to 3 f of u. I have not generated dx yet. du is 2 dx. Correct? So what am I going to have? 1/2 fraction correction. How are we doing? How am I going to get this? Then from -3 to 3, the integral of f of u du. where am I going to go? Back to the graph. And what am I going to start doing? What am I going to do? It's the graph of f. So what would the definite integral from -3 to 3 be? What am I going to do? Start adding up those numbers, right? 5 plus -4 plus 5 plus 3. Yeah. All right, I'm not going to do that. All right, it's 9. All right. So that is what I have for you today. You could choose. Those were all kind of medium to tricky, but none of that was easy. All right. So now you're going to choose if you want to, see if you know the other ones. Go ahead. Or there's the journey through calculus, which I would suggest. Yep.
What do we do after AP test?
Well, for a while, nothing. So I'm going to pause this.